Okay, welcome. We're going to go ahead and talk about the unit circle now. So let's just title this Unit Circle. And what our goal here is to put together the angle measures for the unit circle so you can see how they're built, and you could do it if you want to as practice. So let's start. The first thing I want to do is use things I know in degree land. So I'm going to take my protractor and I am going to mark off some angles here. I'm going to mark a point for 30, one for 45, one for 60, and one for 90. And then I'm going to go with one for 120, 135, then 150, and then finally I'm going to do one for 180. Okay, so those are those little marks there, and I'm going to use my straight edge now, and I'm going to put some marks on the circle. And let's see, this first one would be representing 30 degrees. So I'm going to put 30 degrees here. And then I'm going to put a mark at 45. And what I want to do before, I almost forgot to do this, I want to put an opposing mark. We'll get to that opposing mark in a little bit. So let's go back and put that mark here at 30 and this one on this side, and we'll talk about that in a little bit. Okay, so let's go to 60. Let's do that one, and let's do its opposing mark, and this is 60 degrees. And then finally we're going to do 90, and then we're going to talk about some things here. Okay, there's 90, and this represents a 90-degree measure on our unit circle. Why is it called a unit circle? Well, here, let's talk about why it's a unit circle. Because the radius has a length of 1. Then you say 1 what? Well, 1 whatever you want it to be. It could be a 1 meter, it could be a 1 centimeter, it could be a 1 inch, it could be a 1 foot, it could be a 1 yard. I knew one unit circle, the biggest one that I ever knew, had the length of the radius was 1 light year. Okay, that was in the movie Toy Story, and that was Buzz Lightyear. He had his own Buzz Lightyear unit circle, and that's what it was, a Buzz Lightyear unit circle. And the radius was 1 light year. So it was a really big one. Okay, so let's see. What did we talk about in the last video? We talked about in the last video that 180 degrees of angle measure was equal to pi in radian measure land. So let's write that identity here. So okay, that's an identity. When the left side equals the right side, I'm going to use that word for identity. And so 180 degrees is equal to pi radians. Now I didn't talk a lot about the fact that I don't have to write the word radian there, but as time goes on in trig, we'll learn why that's important and why it really doesn't have a dimension or a label that's given to it. So what's the relationship between the two? It's that identity that we're going to use. Now another one a lot of people like to use is that 360 degrees is equal to 2 pi radians. So we might sometimes think in that land or realm. But I think this 180 is equal to pi would be a good one to start with. So now what is the radian measure for a 30-degree angle? Well, here's how I would do this. Okay, I would say that I'm going to do the work down here. I would say that, well, an identity, the neat part about it is I can write that as what's called a conversion factor. So that identity, 180 degrees is equal to pi radian. Okay, I could divide both sides by 180, and if I do that, divide both sides by 180, I get 1 on the left. 180 degrees divided by 180 degrees is 1. So then if I take and divide that on the right side, I get a ratio, and that's pi radians is over 180 degrees. Okay, pi radians over 180 degrees. This is 1. Okay, so 1. So I can multiply that number times anything I want, and we call that a conversion factor. Let's get this straight. 180 degrees equal pi radians is called an identity. 1 equals pi radians divided by 180 degrees is called a conversion factor. We could also write it as an inverse. We could write it 180 degrees over pi radians. Okay, and so both of these are what are called conversion factors because we're going to use it as a factor. We're going to multiply something by 1, and we're going to use conversion factors for that. Okay, so now we know how to convert angles, and we're going to show an example now. So now the question is, how do I make 30 degrees into radians? Well, I multiplied by 1. So here's what I'm going to do. I'm going to multiply 30 degrees times 1. And which one of these do I want to use? Well, if I have 30 degrees on top, I want to use the degrees on the bottom. So I'm going to multiply it by pi radian, okay, divided by 180 degrees. Now you notice these degrees cancel out, and then I have 30 divided by 160. And really what this does is just simplifies into pi over 6 radians. Okay, now we'll keep using radian there over and over until we finally realize that we do it just for convenience. Okay, but 30 degrees is equal to now pi over 6 radians. Okay, now we could jump to 60 really quick. Why could we do that? Well, because we know 60 is twice what 30 is. So 2 times 30 is 60. That must be 2 times pi over 6. So what is 2 times pi over 6? Well, 2 times pi over 6 radians is, we notice the 2 and the 6 reduce. We end up with pi over 3 radians. So we get pi equals pi over 3 radians. Okay, and then I'm going to go and say, well, wait a minute, 30 times 3 is 90. So pi over 6, we'll just do the math here. On the bottom, we're going to do pi over 6 times 3 is just pi over 2. Okay, so what does that mean? Well, that means that 90 degrees is equal to pi over 2 radians. Okay, radians, pi over 2 radians. So we've got, oh, we forgot 0. Zero's 0. Well, it used to be a song. 1 is the loneliest number that you ever... Okay, well, 0 is pretty lonely because he wasn't taken care of. So that's 0 degrees is equal to 0 radians. Okay, so now we have quadrant 1 all done. Well, what about the rest of the circle? They're wanting to be done too. So let's just go ahead and put in the rest of these. Okay, we remember before we said this was 120. So that's going to be 120 degrees. And then we'll go here to then 135 degrees, and then we're going to go to 150 degrees. Let's put the mark for 150. There's 150 degrees. Oop, and I forgot to put the opposing marks in. So let's do that really quick before we forget. Okay, so boom, 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 boom. Let's get this another one done. Okay, boom, boom, boom. And let's get the one down from 90 here. We'll fill these all in pretty quick. Okay, now I refer to these angles here as, in my classroom, I call them building block angles. Why? Why do I call them building block angles? Well, watch how simple this is. Let's build 120. Well, what do we build 120 out of? It's just twice 60. So why not just say, it's simple. Take the building block, pi over 3, and double it. So we know that 120 is 2 pi over 3 rads. Okay? And now, what about 45? Oh, we never got to 45, did we? We forgot 45. We better take care of that. What do we know about 45? 45 is half of 90. So wait. What's pi over 2 divided by 2? Okay, pi over 2, what's half of pi over 2? Isn't dividing by 2 the same as multiplying by 1/2? So let's go down here in work zone. Okay, pi over 2 times 1/2, that would be pi over 4. Okay, pi over 4. Let's put pi over 4 here. So what we have is 45 degrees is pi over 4. Radians. We don't want to mess up. Radians. Okay, now we got it. So let's use all these angles to build the building blocks. Okay, we got the foundation. Quadrant 1 is our foundation. If we know everything from quadrant 1, we will definitely do the rest of the unit circle. So let's do it. So how many 45s make 135? Wait a second. 1 of them, 2 of them, 3 of them. So if that's pi over 4, that must be 3 pi over 4. 3 pi over 4 radians. I just put the R there. Okay, now 150. Wait a second. 150. 30 goes into 150. How many times? 5 times. So 5 times pi over 6. So 150 is equal to 5 pi over 6 radians. That's it. Oh, we forgot the straight edge. We forgot 180. Let's put 180 in here. 180. So quadrantal angles, 0, 90, 180, 180. And that's the identity that we use. 180 degrees is equal to pi radians. Now, what are these other angles? Well, wait, what are these other angles? Hold on. Well, if this is 30 degrees just shy of 150, this must be 30 degrees just shy of that way. So how many 60 degrees were there? Or 30 degrees? Wait, 1, 2, 3, 4, 5, 6, 7. 7, 7, 7, 7. What angle is that? Well, what is 7 times, what is 7 times 3? That's 21, right? 7 times 3 is 21. This must be 210 degrees. And 210 degrees is equal to 7 pi over 6. My building block, there's 7 building blocks to get down to there. So what do I go here now? Oh, this is a 45 degree type angle. Aha, 45 degree angle. Must end in a 5. Okay, what kind of 5? Well, wait a second. That's 0, 4, 5, 1, 3, 5. How about 2, 2, 5? Do you see the pattern? 225 degrees. We want to memorize that one. And how many 45s does that make up? Let's see. That's 1/4, 3/4. How about 5/4? How about 5 pi over 4 radians? Okay, we're almost there. So now, what do we have now? We have, this is a 60 type angle. Watch. 60, 120, 60, 120, 180, 60, 120, 180, 60 more. 6 plus 18 is 240. 240 degrees. And how many radians is that? Well, the building block for that is pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 4 pi over 3 radians. Now this is 270 degrees, 3 times 90, 270 degrees. And now that's a 1 pi over 2, 2 pi over 2. Now this is 3 pi over 2 radians. Okay, we got it, 3 pi over 2 radians. We're almost done. We're almost out of time too. So let's go, let's continue. So what do we have here? This is what building block is this? What building block is this? Well, it's 30 degrees beyond 270, 30 degrees beyond 270. That must be 300 degrees, okay, and it's getting real hot in the oven. But nevertheless, what's the building block? The building block is 60. 60 times 5 is 300. So that's going to be 5 pi over 3 radians. And then we have this 45 degree type angle. Watch. 0, 4, 5, 1, 3, 5, 2, 2, 5. How about 3, 1, 5? Do you see the number pattern? 315 degrees. And what is that? Well, how many do we have now? We have 45s. We have 1, 2, 3, 4, 5, 6, 7. How about 7 pi over 4? And if you forget that, okay, it's 45 less than the whole thing around. And isn't the whole thing around really 360 degrees? Or 2 pi radians? Or how many ways could we say that? Couldn't we say 2 pi radians is 8 pi over 4 radians? And that's one building block of 45s shy, and that's how we're going to go from there to there. Okay, a lot of stuff to get, but once you get it down, you get it good. It's really, really easy. So the last one, what is the last one? It's 30 degrees shy of 360. And what is 30 degrees taken from 360? It's 330 degrees. 330 degrees, and that is now going to be let's see, 11 pi over 6. It's 11 building blocks, right? Well, wait a second. How many building blocks make up the whole thing? Well, this is also 12 pi over 6. So one building block away would be 11. So how do we remember this? Okay, watch. Let me show you the building blocks, the little ones. This is 1 pi over 6. 1, 5, 7, 11. 1, 5, 7, 11. 1, 5, 7, 11. And I'll get into that a little bit more, but basically, I just like going to 7-Eleven. I get a Slurpee. So I call those Slurpee angles, 1, 5, 7, 11. Okay, what are the other angles? 1 pi over 3. 1, 2, 4, 5. 1, 2, 4, 5. 1, 2, 4, 5. 1, 2, 4, 5. So what do I do? For the little building blocks, for the pi over 6 types, it's 1, 5, 7, 11. What are the other ones? 1, 2, 4, 5. Okay? Now that's the angles of a unit circle. I want you to make sure you know those angles thoroughly. We've got to have those memorized. We've got to know all those, just like they're 2 times 4 is equal to 8. Okay? Have fun with it. Good luck.